Hello guys, I am Zhongcheng from AIT. Today I'm telling you about the calculuses application. First, let's begin with applications of derivative. Derivatives can show us the instantaneous rate of changes, which is incredibly valuable. Let's consider cost functions. The total cost function represents the overall cost of production at a given output level. The derivative of this function gives us marginal cost, the cost of producing one more unit. This is essential for pricing strategies and efficient production planning. Similarly, the average cost function derived by similarly, the average cost function derived by dividing total cost by the number of units, and its derivative help determine how average cost change with production levels, informing smart decisions on scorings. Now let's look at the revenue. The total revenue function shows the total income from sales. Its derivative marginal revenue reveals the extra revenue gained from selling one more unit. This is crucial for maximizing profits. The average revenue function and its derivative allows us to see how average revenue changes based on production levels. Profit function. The difference between total revenue and total cost is the ultimate goal. The derivative of the profit function reveals the marginal profit, the profit from one extra unit. This helps determine whether to increase or decrease production. Similarly, understanding average profit and its rate of change provides further insight into the profit picture at various output levels. Okay, now let's see the examples. One key application is maximizing revenue. By calculating marginal revenue, we can identify the production level that yields the highest revenue. Understanding the relationship between pricing and the revenue allows for strategic production optimization, leading to better business outcomes. On the production side, marginal cost analysis is crucial too. Calculating the marginal cost, the derivative of cost function helps the factories determine if increasing production is worthwhile at the current prices. It can increasing the profits, so it's really important for the factories. Then you can say the ultimate goal is profit maximization. The profit function found by subtracting total cost from total revenue. When analyzed using derivatives, it well reveals the optimal production level for maximum profit. Let's move into a different application. Moving to a different application, integral calculus is essential in engineering, especially in calculating volumes. The washer method allows us to calculate the volume slide form by revolving a region around an axis technique with broad use in design and manufacturing. The washer method, an integration technique, is especially helpful when the region being revolved has a hole, creating a washer-like shape. The formula for calculating the volume involves integrating the difference between the squares of outer and inner radii of the washer. You can see the steps below. First, identify the region, determine the curves, and bound the region you want to revolve and the axis of rotation. Then you can determine the radii, find the outer and inner radii of the washer. The outer radius is typically the distance from the axis of rotation to the outer curve, while the inner radius is from the axis to the inner curve. Then you can set up the volume integral to calculate it. Let's briefly walk through the example of using the washer method to calculate the volume of a slide of the slid revolution. You can see volume of slide formed by revolving the area between these two equations around the axis. First, you can identify the region, then you can determine the radii, and you can set up the volume integral. That's what we talked about last time. That's what we talked about then. That's what we talked about just now, and you can complete the integral. The definitely integral can be evaluated to find the volume of the slide. The result gives the total volume of the area revolved around the x-axis. Okay. In physics, calculus helps us to understand concepts like moment and the center of mass, critical for analyzing rotational system and the balance of the object. Okay, let's then I will briefly talk about the concepts. The moments is calculated as a product of the force and the distance from the point of rotation to line of action of the force. Moments are crucial for analyzing torque in rotational system. And the center of mass of an object is the point at which all the mass of the body can be considered to be concentrated. For the systematical and the uniform bodies, the center of mass can often be found at geometric center. The center of mass is important for understanding how an object will move and balance. Then let's see the examples. This method, the center of mass can consider a uniform road. Imagine a road of length, and that is uniformly descent. Determine the coordinates. Sorry. If we place the road along the axis, ranging from 0 to length, the mass of road is evenly distributed, and you can calculate the center of mass. That's it. Okay. In conclusion, calculus is far from a purely theoretical subject. Its applications are wild spread, influencing business decisions, engineering decisions, and our understanding of physicals. It empowers us to model thematic system, optimize processes, and solve complex problems in a variety of fields. That's my representation. Thanks for listening.